we're talking about properties of rational exponents and radicals. And here we want to simplify the following expressions, assume that all variables are positive. So here we have the cube root of 27q to the 9th. And in order to simplify this, we want to try to pull things out of the radical. In order to pull things out from underneath the radical, we need to have sets of 3 in this case, because that's the radical. So we can rewrite this. We can write this as the third root of, and we know that 27, we can rewrite that as 3 to the third. So that's one set that can get pulled out. And we can rewrite q to the 9th as q to the third, q to the third, and q to the third. So what that means is we can pull that many things out. So, and actually, because all of these are cubed and we're dealing with the third root, there's not going to be anything left under the radical this time. So we can simplify this to the cube root and the cube cancel out. So we're just left with 3. And then we can pull all of these out. So we have 1, 2, 3. So that's going to be pulled out as q to the third. If we wanted to write this out all the way, maybe to illustrate it a little bit better, we could write this as 3 to the third, or cube root of 3 to the third, which is 3 times 3 times 3. And then q to the 9th, that's just q 9 times. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we can see that we have to pull sets of 3 out. So there's one set of 3. There's 2 sets of 3. There's another set of 3. There's another set of 3. And there's nothing left to leave under the radical. So we pulled 3 q's out. 1, 2, 3. That's q to the third. And then we have 3 to the third, which we pulled out as 3. All right, if we're looking at the next example here, we have the fifth root of 10, or x to the 10th, divided by y to the 5th. So in this case, we can rewrite the numerator as the 5th root of x to the 5th times x to the 5th. And in the denominator, we can write that as the 5th root of y to the 5th. And so what we can pull out of this one is we have one x to the 5th and another x to the 5th. So that comes out as x squared. And in the denominator, we have just one set of y to the or of 5 y's. So we can that just stays as x squared divided by y. Okay, the next example, this one is subtraction. So in order to subtract things, we need to make sure that we have a common, we have to have like terms. So in this case, we have the square root of 9w to the 5th minus w square root of w cubed. So we need to make whatever's under the radical be the same in order to subtract this. So one thing that we can do is we can simplify what's going on under the radical. So we can take the square root of 9, which is 3. And we also see that we have 5 w's, so w to the 5th. But we just need to have sets of 2. So this w can be written as w, 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 w. So what that means is we just need sets of 2. So we can take out 1 w and then 2 w's, but we still have 1 w left under the radical. So we have w squared. That's what we took out of the radical. And then we're still left with 1 w. Then we can subtract. In here, we have 3 w's. If we're just looking at this, we have 3 w's. So we can take 2 of the w's out. and join them with what's already there. So that becomes w squared. And we still have one w left under the radical. And so that becomes w. So now we have like terms here. We have w squared times the square root of w, and we have w squared times the square root of w. So those are like terms now, and we have the understanding that there is a 1 out front. So in this case, we say 3 minus 1, that is 2, and then we have the like terms, so we just leave whatever's there. So that becomes w squared square root of w, and that is the simplest form. And we have another example where we have 6xy raised to the third 3/4, and then we have 3 times x to the 1/2, y to the 1/2. And what we want to do is we can take our coefficients that are out front, because it's multiplication, we can just join those together. And so we can say 6 divided by 3, and that is equal to 2. So so that is what we can simplify our coefficients to. And then we have to look at what our like terms are. And so in this case, we have x, and we have x to the 1/2 power in the denominator. So what we can rewrite that to be is, we can say it's understood that x is to the 1, so x raised to the 1, our first power, and then we can subtract x to the 1/2, because that's in the denominator. And so what happens is we move it to the denominator, or to the numerator, as a negative. So we can subtract those together, subtract those two, and we get x to the 1/2. That's what we're left with. And then the last part we have to deal with is we have our y's. So in the numerator, we have y to the 3/4, and in the denominator, we have 1/2. Well, another way to write 1/2 is 2/4. So then we can subtract y to the 2/4, and what that leaves us with is y to the 1/4. See if I can fit it in there. Y to the 1/4. So by canceling what was in our numerator with what's in our denominator, we can simplify that fraction as simple as we can get it.